Good afternoon, everyone, and welcome to today's session. Just before we get started, please put your devices on silent and be aware that all sessions are recorded and live streamed, so they'll be available after the session. So welcome to the session on Insight on Demand, building your intelligent data agent. It's my pleasure to welcome on stage Surya and Jan from AWS.
Good afternoon, everyone. We have reached till the end of a very long day. And in this last session of the day, I would like to start by asking ourselves two questions. How often do our business leaders find that their dashboard doesn't contain all the information they need for a critical business decision? And how quickly can we retrieve that data? We are talking Insight on Demand here. Hi, my name is Surya. I am a solutions architect. Joining me, Jan, who is also a solutions architect. Let's jump in. Looking at an agenda, so we will do the why analysis by discussing about the challenges the current data team face and how this intelligent data agent help in resolving some of those challenges. We'll see the agent in action through a quick demo, and then Jan will take you through the design and the architecture of the system. We will wrap up by best practices. In order to spice things up, we have come up with a very short story about a fictitious e-commerce company. So these are some of the characters in our story. Lucy, the product owner. Jake, the data analyst. Clearly, both of them don't look really happy. So what's the reason behind it? So here is the backstory. Lucy has been tasked with increasing the sales of a specific product category by 50%. She's a strong believer of data-driven insights, but she needs some data from the previous campaign. She went and searched in the dashboards. It's not available there. She doesn't have the time, skills, or tools to go and fetch it herself. Now she reaches out to Jake and his team. But unfortunately, Jake and his team, they are overwhelmed with 3 other similar request, and also they are in the middle of a very time critical business high value project. They don't have any spare time to help out Lucy. Research show that 30 to 40% of data team's time is spent in responding to ad hoc requests. And we know that when business need data, they want it immediately because any delays in action can be a lost opportunity. So in this case, Lucy has to wait, and Jake and team is overwhelmed with work. Let's imagine a world where Lucy doesn't have to wait. So she has this virtual assistant with whom she can constantly communicate about the data from her enterprise data store. So it could be questions like how many products were sold, which customer segment responded well in last campaign, or what are the trends. So she can keep on talking to the virtual assistant just like how she would talk to a human. Now, Lucy can take actions faster because she has the capacity to go and independently explore and analyze the data, all by herself in plain natural language. Now, how about our data team? They are now free of any ad hoc queries. We actually don't want to do any ad hoc queries, right? We want to focus more on more high value business strategic projects. So who is this intelligent data agent? You can think of it as an intermediary between the business and the enterprise data store. Here, when I say enterprise data store, it could be your data warehouse, data lake, anything, any of that data. Now, this agent can understand the natural language. It knows exactly what actions to take. It knows your data sources. And also, at the same time, it complies with the organization's data access policies and governance control. It empowers the business users to independently go and explore data so that they can take data-driven decision much faster. So having heard about all these things about the data agent, you might want to see the agent in action. So in this demo, I'll be showing you two different personas interacting with the agent. So user 1 signing in and communicating with the agent, and then user 2 communicating with the agent, and how the agent responds differently with these two different users. So first user signing in through the organization's identity provider. So in this case, I'm using the AWS IAM Identity Center. After that, the agent is ready for a chat. So the first question, so you can see that I have logged in as analyst role. And my first question, how many orders were received in April 2025? So there is a number, 6842. That many orders were received. How many were cancelled? So note that I haven't mentioned April or orders, still it knows about the context. Yes, 340 orders were cancelled in April 2025. Now, my next question. Okay, I'm curious to know which customer made these cancellations, like highest number of cancellations. Agent comes back with a customer ID 04795, and that person made 4 cancellations. All right. So let me check whether it gives me the customer name and phone number. This is a PII data, and for an analyst role, yeah, agent is not retrieving the data. I'm not sure whether the agent stopped working or it's just not giving you that data. So I ask one more question. City of the customer? Yes, the city information has come back. So the agent does not give you the PII data when you are logged in as an analyst. I can keep on asking other questions like which product received maximum cancellation and things like that. Now I will sign off from this session and log in using the next role. Okay. There's a wait there. Okay, I'm logging back in. I will ask the same set of questions again, just to make sure that whether the agent is hallucinating, making up some numbers and giving me, or is it really retrieving data from somewhere. So number of orders in April 2025, we got the same number. Regarding the cancellation, yes, so that number is also matching. Basically, I want to make sure that I'm getting same response for all my previous queries, and the agent is giving me the same response. So back to my the favorite question, who made maximum cancellations? I want to know that customer. Again, the agent is first giving you the ID. It's not giving out any other details. It's giving you the ID and how many cancellation that person made. I'm explicitly asking with my manager permission, give me the name and phone number. Yeah, and the agent is giving me the name and phone number of the customer. So yes, so you can see that the agent is responding differently with different roles. So based on who is talking to the agent, agent's response changes. Now, where is this filtering happening? And is the agent learning from the retrieved data? In order to find that out, let's jump into the architecture. I would invite Jan and talk us through the architecture. Over to you, Jan.
Awesome. Thanks, Surya. Just a quick check, can everybody hear me? Nice, awesome, thank you. So just a very quick recap. We were having this scenario of two users, let's say Lucy and her manager, interacting with our agentic application. But when it comes to the data, where does it actually come from? What powers this? And the answer is Bedrock knowledge bases. So just a show of hands, has anyone worked with knowledge bases before on Bedrock? I see a few. Awesome. Let's do a quick recap. So let's take the scenario of me being maybe that unhappy customer dealing with the cancellation of that product, and I want to learn about the return policy. So imagine that the e-commerce store has the like support agent, and I'm going to ask a question, what's the return policy for the item? In the traditional sense, with Bedrock knowledge bases, I'm going to look at, okay, we've got a knowledge base, we've got our documents ingested here, so there will be a return policy for our products. And then it gets passed to the prompt that we've got with our large language model. And through RAG, or retrieval augmented generation, we then pass the context to models such as Amazon Nova or Anthropic Claude. And then lastly, it gets formatted for the actual customer. So we can see, if you've got issues with that product, this is the return policy. So this is usually how the Bedrock knowledge bases used to work. But when it comes to the e-commerce data that we've got, it's not really sitting in a document that we could just read. It's not a PDF or anything. It usually looks something like this. We've got a table, and in that table we've got, for example, orders. So you can see the date, the customer ID, product ID, lots of IDs, right? So when it comes to this information, it is actually consisting of multiple tables, right? So we've got our products, we've got our categories. And when it comes to structured data, this is not really the end list, right? There will be tens, hundreds, thousands of tables. There will also be a lot of data, so it will be millions of rows. So when it comes to retrieving the data from the structured data, it's actually a very different story. So last year at reInvent, we had a new types of knowledge bases come out for structured data. So how do they actually work? It starts the similar way. We've got a query here, we've got a question, how much did we generate, for example, in January in sales? It then gets passed to the Bedrock knowledge bases, the structured type. But then instead of retrieving the data, we actually translate that natural language to SQL. Then we pass it to one of our backends. So in this case, it could be data store, Redshift, or SageMaker Lakehouse. So we retrieve the data. And then lastly, again, using large language model, it gets nicely formatted and passed on to the user. But you might be asking the question, well, Jan, we had large language models trained on SQL statements. So why do we need structured knowledge bases? What value does it actually add? Well, when it comes to natural language to SQL, it's actually a little bit more complex than just this. So imagine this query, right? Like different scenario. We've got schools and we've got test takers. And if I would just pass this to a regular large language model, it will come up with a translation something like this. Right? We've got, it all looks good. But in my case, for my database, I actually have maybe the same table name, but I've got different columns. And maybe I need to actually perform those joins. So the bottom line is we actually need to know about the tables, about the structure, about the schema, to be able to actually translate that natural language to SQL. But it goes further. It's not just the schema. So in this case, again, I'm going to be looking at gas stations in Czech Republic. And again, provided we've got the right database, right schema, it's gonna build a query. But in my case, I'm actually not storing the countries as a full name. I've got my countries as an ISO code. So it's not just about the schema, it's also about the data. And lastly, we've got the schema, we've got the data, but we can have different database engines. So what this means is, even though it produces the nice output, like the translation from natural language to SQL, it might actually be syntactically incorrect. And we need this to be syntactically correct every time, because we then pass it over to the data store, which needs to provide us with the data. So again, in this case, maybe we have prefixes of our tables to columns, and we have different keywords like group by instead of group, and order by. So it really comes down to knowing these specific details. So all of this translation comes with structured knowledge bases in Amazon Bedrock. And what we can do as architects as well in building the system, we can help it with providing more context. So describing the tables and columns, right? So if there's ambiguous naming, we can give it some helping hand. What we can also do is provide curated queries. So what this means is I will have a natural language question, and then what resulting query it will actually produce. So let's say in this case, if I'm talking about the sales for a particular category in a month, then if somebody else asks for a different month, the structured knowledge base already knows how to actually work with that. And lastly, I can also look at the inclusions of and exclusions, so maybe limiting to particular tables or columns even to make it more accurate. But when it comes to structured knowledge bases, they don't just do the translation, they can also do the retrieval. But in our case, for our intelligent data agent, we have multiple different personas. So we need to add another component into the mix, which is agents for Amazon Bedrock. I'm sure if you watched the keynote, you could see how agents are actually helping our applications. But for our case, we're really looking at breaking that operation into two different actions. First one is being that natural language translation, so from natural language to SQL. But then we take the SQL and apply the current user permissions to retrieve the data from the data store. So here's the end-to-end picture. We've got our users interacting with the application, so logging in and having our session. Then we pass on to the Bedrock agent, and we retrieve we do the natural language query translation. So we're interacting with the database metadata. But then the step two is actually taking that SQL that was translated and then passing it on with the credentials to retrieve the data from the data store. So this is the end-to-end picture for Intelligent Data Agent in terms of architecture. I'll now pass back to Surya, and she's going to take you through the best practices for this design. Thank you.
Thank you, Jan. I'm back again. So, in order to make our system safe and protect our data, there are some guidelines that we should be following. The first one, no-brainer, the end user should be authenticated. The second one is, yes, very important. The agent should be working within the scope of that end user's role. And only the data that the authenticated user is authorized to access, only that data is retrieved. We are talking principle of least privilege. With strong data access policies, we can have that strong role-based access controls. If you don't have one in your organization, I would highly recommend that you all go and establish it. Data encryption in transit and at rest. Here we saw that we are not taking the data away from our data store. The knowledge base is storing only the metadata. No data is stored in the agent or in the model anywhere. It's all in the data store, and then you are securely accessing that data. Last, the audit trail and compliance. All the systems and tools we used in this design is compliant with industry standards like SOC 2 and HIPAA. And audit trail is crucial for finding that access patterns and who is accessing the systems, etc. In order to make a very cost optimal but performance system, some guidelines validate the user input. Here, make sure that the end user is using the agent for its intended purpose. Not like, questions like how to make a cup of coffee, unless you are in the restaurant industry. So always validate the user input. Right sizing of the model. So you can see that Bedrock offers a variety of models. So always choose the model, go and check the model card. There is a model card associated with every model. Check the model cards and then pick the one that is appropriate for your business use case. You can probably start with the medium and then try to see how the model is performing and then adjust from there. Prompt template management. So prompting is the instruction to the agent. So it's very crucial, and you need to have a clear, concise prompt. And this prompt should be regularly reviewed and refined. You can use the Bedrock's prompt template management for this purpose. Rate limiting, because here we are dealing with foundation models and the enterprise data stores, etc. We don't want to just bombard it with a lot of queries, right? We don't want to do the model invocation many times. So rate limiting, that will help your protect your system and also for the cost. Applying guardrails for preventing any type of unwanted or inappropriate response. And finally, model invocation logging, so that we know what kind of questions are the end users asking. And also, this logs can go to CloudWatch logs or S3, probably S3 when it is really large logs. And this can be used for analysis, right? So you can see the patterns and trends in questions, and probably that could be a potential candidate for your BI dashboard. So here we are not talking about replacing your existing BI dashboards. It's just another mechanism that will help resolving the data team challenges with all those ad hoc query requests. So after that, now coming back to our characters, after getting this intelligent data agent, Lucy is empowered. She is getting all the data related questions response very fast. She doesn't have to wait for the data team. And data team, Jake, now he can concentrate on his work, which is a high value strategic initiative. So both parties are happy at the end. A happy ending. So here are some links. The first one is will take you to Amazon Bedrock knowledge base documentation. The second link points to some of the code samples, basic code samples to get started with knowledge base. And with that, this is me, Surya, and Jan signing off. Thank you all for sticking with us.
Thank you. Enjoy the rest of the summit.